Okay, welcome to Notes 4.2. This is our literal equation notes. Let's see how we do today. So go ahead and put your name and class period at the top of each of your papers. I'm going to go ahead and put video at the top of each of mine. So when I'm looking through mine, I know that this is my video copy. McNabb. And one more. You should have 4 pages. Okay. Here we go. So this is continuing with literal equations. So let's do a pretty quick review of our vocab that we went over. So an equation, we all know this. 2 expressions with an equal sign in between. That is an equation. See if you can think real quick and come up with an equation on your own. Okay. So I'm going to come up with one. See if you and I came up with something similar or if yours fits the idea of an equation. So we have 6x plus 2 equals 20. 20. So an equation, all it has to be is 2 expressions. 6 plus 2 is an expression. 20 is an expression. 2 expressions with an equal sign in between. So mine is definitely an equation. Yours could, see if yours is too. It can have letters, it can have numbers, it has to have an equal sign in between. Okay, next up, we're going to talk about literal equations. And if you guys remember, we talked about the other day that literal means like literature, literary, literally. Another thing that we can remember is that literal is our letters. We read letters, literature, stuff that we read. So, a literal equation is an equation with more than one type of variable. And again, variables are letters. And today we're going to mostly be working with all letters, which I think is pretty cool. We worked with some yesterday that were all letters too. But we got this. Okay, so some examples of some literal equations. You guys have heard some of these. Y equals mx plus b. Hint preview, we will be talking about that one later. A squared plus b squared equals c squared. That's also a literal equation. And we also have do you guys remember we talked about this example of distribution? A times b plus c equals AB plus AC. That is also a literal equation. You just have to have more than one type of variable. And last but not least, this is old hat by now, inverse operations. Inverse operations are operations that undo each other. So let's go through and write the operations. Add, subtract, multiply. Oh, that's not, I went to write the word multiply. Multiply and divide. Remember, we only use these 2 symbols when we're taking notes. We don't use them actually when we are doing math. The inverse operation of addition is subtraction. That means the inverse operation of subtraction is addition. The inverse operation of multiplication is division. And the inverse operation of division is multiplication. Okay. Last but not least on this first page here, I told you this was going to be quick today. Last but not least on this first page, we do have our rules for how to solve an equation. And just like we have PEMDAS to tell us how to simplify, what order we do operations when we simplify, we also have this guy that tells us what order to do our operations when we're solving. So first we distribute, then we combine like terms. These things happen on one side only of our equation. So these do not happen to both sides at the same time. But then once we get to adding and subtracting, multiplying and dividing, these have to happen to both sides. Okay, so if I'm adding 3, I have to add it to both sides. Go ahead and make sure that you have this page of notes all caught up.
Testing 1, 2, testing 1, 2.
That's exciting. Go ahead and make sure you have this side of the notes caught up. I'm trying to focus my camera. There we go. Make sure you have this page of the notes caught up, and then I will meet you on the next page. Pause if you need to. How much do y'all want to bet there's going to be another interruption from the PA? Yeah, pretty much. Okay, let's do some examples. Whoa, buddy. Miss McNabb, when are we ever going to use this? Haha. Putting it into real stuff now. So today for our examples, we're solving for the named variable. So for example 1, the formula for the perimeter of a square is P equals 4S, where P is the perimeter and S is the length of a side. And something to remember about squares is that they all have the same angles, right? And then they all have the same, all of their sides are the same length. So the formula is P equals 4S. Well, what if I am building a garden and I have, I know, hold on, I'll pause for this because this is long. Okay, my apologies about that one. So we are looking now at, we have P equals 4S. Well, what if I'm building a garden and I know that I have 40 feet of my fencing. So that means my perimeter can be 40 feet. Well, how long does each side need to be? Let's figure that out. So I'm going to solve the equation for S. So right here I have P equals 4S. That means 4 times S. How do I undo multiplication? Division. So I'm going to draw my gate here. I'm going to divide both sides by the one I'm trying to get rid of, which is the 4. Because I'm trying to get my S by itself, remember? And then I have P divided by 4. If I do it to one side, I have to do it to the other. So then that gives me P divided by 4, perimeter divided by 4, equals S. And I have solved for sides, for the length of my sides, solved for S. Okay. Go ahead and get that one, and then meet me on example 2. Okay, for rectangles, we know, hold on, let me see what color I have to do. Y'all know we have to do the right color. So after purple comes green. Okay, for rectangles, we know that P, again, perimeter, equals 2L plus 2W, where P is the perimeter, L is the length, and W is the width. So again, we're using that equation. Solve the equation for L. Okay. P equals 2L. Remember, I'm doing my fancy L's so I don't confuse them with ones. Plus 2W. Okay, and I want to solve it for L. So this is a useful one if I still have my 40 feet, right? But I know that the width of my garden has to be 5 feet. That's all the width that I have. How long is it going to be? Okay, let's see. Let's see if we can solve this. So I know that I'm trying to solve for L. Remember, I can distribute, combine like terms, add, subtract, multiply, divide. Okay, there's nothing I can distribute to solve for L. There's nothing I can combine, no like terms I can combine. Now, is there something I can add or subtract that's going to start getting my L by itself? Well, yeah, I can subtract this 2W, can't I? So minus 2W. If I do it to one side, I have to do it to the other. Okay, so we have P minus 2W. We had P and we subtracted 2W. Those are not like terms. We cannot combine them. Equals 2L. Okay, so we subtracted from both sides. Subtract. Okay, but I still have 2L. Well, I need to get rid of that 2. I know that 2L means 2 times L. So I could undo that multiplication with division. Could divide both sides by 2. Remember, on our other side, if we have more than one term, they get divided up, or they each get divided by 2. So that's going to be P divided by 2, and then negative 2W divided by 2. Okay, so these cancel out. We get an L comes down. Oh, we're taking the L. Oh, so sad. Okay, and then we have P divided by 2 minus, oh, look at this. Do I have a 2 divided by 2 just like I had over here? Oh, by golly, yes, I do. So I can cancel those out as well. Divided by W. You're not always going to be able to do that, but it's bonus fun when you can. So for this one, L, so the length of each of those sides is going to equal whatever that width I have to have is. Well, it's going to equal my perimeter divided by 2 minus whatever that width I have is. That'll give me the length of each side. So to find that, I subtracted my 2W, brought my 2L down. That gave me P minus 2W equals 2L. I said, hey there, I can divide out that 2, but I have to do it to both sides. So that left me with L equals P over 2 minus W. Okay, go ahead and copy that one down. Oh, wait, sorry, what was my last step I did here? I divided. I had to subtract and then divide. Okay, now make sure you got that one copied down, and then I will meet you on the next page for the last example. I know, these were quick, weren't they? Y'all were all concerned because there were diagrams and words, and it was very strange. But look at that. It's not that hard. Okay. Example 3. It's okay. You got it. You can do this. You can do this. It's okay. You got this. We have to evaluate. Oh my goodness. Oh my goodness. Do you guys remember way back at the beginning of the year when we would have an equation and it would give us like, okay, A equals this, B equals that, so you'd have to substitute in? It's back, but now we have multiple variables and they're a little more complicated, but I'm going to show you a trick. So it's not going to be so bad. Okay, example 3. Area, which this is annoying because this is actually, okay, area equals 2W squared plus 4HW, where A is the surface area. So not just the area here, but the area of all the surfaces. So the surface area of a square prism, so that's this guy, with a square base of side W. So we have W and H. Okay, but we also know since this bottom part is a square, it's going to be W, 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 and then H, 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 H. Okay, so they want us, though, to find A if W equals 6 and H equals 10. So we know that A equals 2W squared plus 4HW. We know that W definitely equals 6 because they gave us that. See, they gave us our formula. They gave us our W equals, and they also gave us our H equals 10. And they want us to find A. Well, convenient. It's already solved for A. Oh, thank you, Miss McNabb. You guys are so welcome. Okay, so what we're going to do here is remember, when we go in and we substitute in, we put in parentheses for the variables we're going to use. So we're going to do A, because we don't know what that is yet. We're trying to find that one. A equals 2. I do know what W is, so I can put some parentheses and a squared plus 4. I do know what H is, so I'm going to put some parentheses to hold my place there. W. Again with some parentheses. You're going to see why the parentheses are so helpful in a minute. Okay, so I know that this is a W, so that's going to be 6. And then we had 4, so I know the next one is an H, and that's 10. So 10. And the last one is another W, so that's a 6 again. See if you've got that. Make sure you're caught up on that, guy. Okay, and here comes our favorite BFF in all of algebra. Here she is. You know we love Desmos, right? Guys, I'm not going to sit here and make you guys work this one all out. Here's what we are going to do, though. We are going to copy it in here. Now, we're trying to find A, so we're not going to put A in there because whatever this equals is A. So now that this is all numbers and we don't have any variables, we can just let the calculator do its work. I have no idea why a bell's ringing. It's 4:41. Okay, so now we're going to put just this chunk into Desmos. And we're going to put it exactly as we see it. So I have a 2. I have an open parentheses. I have a 6. I have a closed parentheses. Okay, now I need to do this exponent of 2. So it's not letting me pull up my little calculator here. Hold on. Give me just a second. It's giving me fits. There we go. So I have 2 parentheses 6, and I need to have my exponent of 2. Look at that. Look at that. That's so exciting. So I have 2 open parentheses 6, close parentheses 2, plus, plus 4. This is where the parentheses come in so handy. Y'all try to be lazy about them, but they're going to help you. 4 open parentheses, 10, close parentheses. Again, I have no idea why a bell's ringing. This is a hot mess video. 6, close parentheses. Okay? And there is your answer. A equals 312. Okay, that was not hard, guys. The tricky part there was knowing to write parentheses instead of our variables. And then knowing, hey, I see a W here, so I'm going to put a 6 here. I see an H here, so I'm going to put a 10 here. I see another W, so I'm going to put a 6. And then when we type it in, making sure it is exactly as it goes. 2, open parentheses, 6, close parentheses, squared, plus 4, open parentheses, 10, close parentheses, open parentheses, 6, close parentheses. I didn't have to do any math. It was super easy. So now it's up to you guys. You guys have a couple, 3 practices here that I agree look tricky, but I think you'll agree with me that once you start doing them, they're not as tricky as you think. Okay, so best of luck. Let me know when you need some help.